We're ramping things up in chemistry now, moving from elements to compounds. So just to kind of remind you how this all plays in, all matter is made up of atoms, and then matter can either be pure or matter can be a mixture. And if it's a pure substance, if that chunk of matter you're pointing to is a pure substance, it can either all be atoms of the same type, in which it's a pure element, or atoms can be joined together in repeating units we call molecules or formula units. We call these things compounds. You can go back and forth between elements and compounds by chemical reactions. Just to kind of finish off this thought, if it is a mixture, then you have two or more substances that are just tossed together, just physically combined. If those two or more substances are well mixed and it's uniform, we call that a homogeneous mixture. If it's chunky and you can actually sample it at different places and get different relative amounts of your substances, then it's what we call heterogeneous. So right now, I want to focus on compounds. They are very exciting. So compounds are two or more elements that are stuck together. Now you probably already kind of have a sense of what compounds are. Compounds, then, we use, we have to say in a compound what atoms are joined together. So for instance, water, everybody knows, is H2O. So we have two hydrogen atoms and one oxygen atom that are in the repeating unit of a water, what we call molecule. Carbon dioxide, the formula is CO2. Ethane, we have two carbons, 6 hydrogens. Calcium sulfate, we have 1 calcium, 1 sulfur, and 4 oxygens. Now I want to kind of take a look at this last compound down here. So this last compound, I hope you can see it, actually it's Mg, 1 magnesium atom, and then what we do is something kind of like what they do in math. Can you see the parentheses around the NO3, and then outside the parentheses is the number 2. So actually that 2 right here means 2 of these. So if I was going to draw a picture of Mg NO3 quantity 2, it would look like this. We have the Mg probably kind of in the middle, and then we have 2 units of NO3. So here's 1 unit of NO3, and here's another unit of NO3. And we're going to be talking more about this a little bit, but notice how I have drawn, oops, I guess I need to erase this. Okay, notice how I have drawn like solid lines here. And actually that's one type of bond. And then what I'm going to do is draw a dot, 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 and that's my other type of bond. My point here was going to be to see that this actually is this, okay? So if I were to ask you how many oxygens, hopefully you would see that since that NO3 is in parentheses with a 2 outside, I must have 2 NO3 units, just like I'm showing you here. So I'm counting, what, 6 oxygens? Okay, so that's kind of what I wanted to emphasize there.